So this note is on simplifying rational expressions. Many of you don't know this, but a rational number is just what you think of as a fraction. So we can simplify rational expressions the same way that we can reduce rational numbers to lowest terms. So what we're going to be doing today is we're going to be thinking about fractions, but now they're involving polynomials and variables and coefficients. So if I asked you to simplify 10 over 15 in your head, I'm sure that a lot of you, would right away just be able to tell me that that was 2 over 3. What you're probably not doing in your head is doing 5 times 2 and 5 times 3. So 5 times 2 gives you 10, 5 times 3 gives you 15, and then you're probably not thinking about crossing out these 5s. Maybe some of you in your head thought that you would divide this by 5 and divide this by 5 to get the 2 over 3. But basically what we're going to be doing today is we're going to be doing exactly this. So in our first example today, I'm going to ask you to simplify the rational expression and state the restrictions. We haven't really talked about restrictions. Restrictions are just basically a number that we could never plug into this expression. So we know in math that we're not allowed to divide by 0. It's like one of the biggest math rules. So our denominator is never going to be able to be 0. So before we think about restrictions, we're going to simplify this. I can't really simplify the top, it's just an x, I can't do anything with that, but I can factor this bottom, so I'm going to common factor out a 2x, and once I do that I'll be left with x minus 2 in brackets. So now that I have this factored out, I have two options. Option 1, I can start canceling things out to simplify, and option 2, I can do the restrictions. I like to do the restrictions right now, and if you wait till the end, I'll show you why that's not necessarily a good idea. So what numbers do we have for restrictions? So right away I know, here I'll just write restrictions here. I know that x cannot be 2. And the reason for that is that if I plug in a 2 here, I would get a 0 in this bracket, and so anything times 0 is 0. I know that that's not allowed. Same thing, I have to think, what number could I plug in here to make that 0? And the answer is 0. So if I plug in a 0 for x here, I would get 2 times 0, which is 0, and that's not allowed either. So my restrictions are done. Now I can go ahead and I can start simplifying this. So I see an x on the top and an x on the bottom, so those can cancel out. And once I do that, I'm going to be left with just a 1 on the top, and then a 2 times x minus 2 on the bottom. Now, just to quickly tell you, I cannot cancel out I cannot cancel out this x with this x. This x is part of this bracket. I can't just get rid of something there. The only reason that I could do that here is because this is just a single term, so I am allowed to get rid of the x here. And I just wanted to give you one quick little reminder before we do some more examples. So I wrote here, remember, division distributes over addition. So my example is x plus y over 3. I could break this up and I could rewrite it like x over 3 plus y over 3. Think about it like the opposite of when we were adding our fractions. If the denominator was the same, we could combine the numerator, and this is the exact opposite of that. And the reason why I'm telling you this is because it does not distribute over multiplication. So if I had x, y over 3, it does not equal x over 3 times y over 3. That is not true. Please don't ever do this. And it probably makes sense that this isn't true when you really think about it, because you know that when you multiply, you would do top times top, which would give you the xy, but then you would do bottom times bottom, which would give you 9, not 3 like you wanted. So if I was going to rewrite this, if I was going to rewrite xy over 3 as something, I could write it x over 3 times y Or I could write it like x times y over 3. Those are both possibilities that are true. So thinking about what we just talked about on the previous page, if I had x plus 3 over 3, I have a lot of students that want to just cancel out this 3 with this 3, and they want to say that this is equal to x plus 1. Like they're thinking that this 3 and this 3 would cancel out and just leave me with the 1. That is absolutely not true. Please do not do this. We know that if I had x plus 3 over 3, I could rewrite this as x over 3 plus 3 over 3. Remember, this 3 in the denominator would have to be distributed into both terms in the numerator. And so I could simplify this a little bit. I could say x over 3 plus, I know that 3 over 3 can be simplified to 1. So please know that this is not okay. This is not allowed, but this bottom is. All right, so we are going to simplify these. So I have a squared minus 7a plus 12 over a minus 3. The first thing that I'm going to do is factor out anything possible. So I'm going to factor out this numerator. It's just simple. I need something that multiplies to 12 and adds to negative 7. So that I know that's going to be a minus 4 and an a minus 3. And the denominator is already factored for me, so I don't have to do anything there. Once I factor, like I already said, I like to write my restrictions right away. So the only restriction that I'm going to have here is that a cannot equal 3. I know that if I plug a 3 in here, that would give me 0 on the bottom, and that is not okay. So my restrictions are done. Now I can go ahead and cancel out anything possible. I have an a minus 3 on the top and an a minus 3 on the bottom. And so when I simplify this, all I'm left with is a minus 4. And this is the exact reason why I like to do my restrictions right away as soon as I factor everything. Because if I just looked at this simplified version of a minus 4, I'd say to myself, oh, there's no restrictions. There's no fraction here. There's no denominator. So a could be anything that I wanted it to be. But that's not true. Just because I canceled it out doesn't mean that that restriction goes away. All right, I've got x squared plus 3x minus 10 in my numerator. So again, this is just a simple trinomial. I'm going to factor it. What multiplies to negative 10 and adds to positive 3. I get x plus 5 and x take away 2. My denominator is another simple trinomial. What multiplies to 15 and adds to 8. X plus 5 and x plus 3. I'm going to write my restrictions right now. This bottom one, x cannot be negative 5. And then this one, x cannot be negative 3. At this point, I can go ahead and cancel out whatever possible. And so I'm going to be left with x minus 2 over x plus 3. All right, questions like this next example get students all the time. So when I look at this numerator, there's nothing really that I can factor. When I look at the denominator, I can factor out a 2. So I'm going to factor out a 2 and I'll get, whoops. There we go. I'll get 2x minus 3 left. Now students are going to say, Miss G, I can't cancel anything out. Nothing matches. But there is something that we can do. So when I look at this, in my numerator, I see 3 minus 2x. And in the denominator, I see a 2x minus 3. These look the same, but with different signs, okay? They're switched. So that means that I can factor out a negative 1 to make them look similar. So what I'm going to do is I'm going to rewrite this top line. So instead of saying 3 minus 2x, I'm just going to rewrite it to say negative 2x plus 3. I haven't done anything at this point. I've just switched the order, but I kept the sign the same. So I kept the negative in front of the 2x and I kept the positive in front of the 3. So I haven't done anything. But now what I'm going to do is from the numerator, I'm going to factor out a negative 1. And if I do that, then this negative 2x changes to a positive 2x, and this positive 3 changes to a negative 3. Now, before I go any further, since this is just factored, I'm going to state restrictions. So the only restriction that I have on this one is that x cannot equal positive 3 over 2. Now, I did a lot of work here. I'll just write it quickly. 2x minus 3 cannot be 0. 2x cannot be positive 3. I move that to that side. And then x cannot be 3 over 2. So that's how I got that. Now, I'm going to cancel out these brackets because now that I factored out these -1, these brackets are both the exact same. And after all that work, what I'm going to be left with is just -1/2. So the next couple of examples are a lot trickier. It's not just simple trinomial factoring. Now we're going to have to do decomposition and even some special products. And so what I'm going to say is at this point I want you to pause the video. I want you to attempt to factor these and then restart the video as soon as you have them factored. All right, so I factored this for you. Obviously, I haven't shown any of the work, but this is what you would get. Since everything's factored, I'm going to go ahead and state those restrictions. So y cannot be a positive 1 over 4, and it cannot be a positive 3. That looks kind of silly, but there you go. And at this time, I can cancel out the y minus 3's. And so what I'm going to be left with is just 2y plus 5 over 4y minus 1. I'm going to get you to do the exact same thing. This is a special case on the top. It's a perfect square. And then pause the video, come back, let me know what you've got. Once this is factored, what you're going to see is that this is another one of those tricky examples where I have a 3x minus 4 on the top and a 4 minus 3x on the bottom. So this means that I need to be factoring out a -1 from the bottom so that I can get it to match the top. So this is going to be a -4 plus 3x, which I know that I can just rewrite as 3x minus 4, so just switch those. If you wanted to cancel it out at this step, I'm okay with that as well. So this and this go away, and when I simplify, I'm left with just -3x plus 4, or if I wanted to distribute that through, a -3x take away 4. And I forgot to do my restrictions. I'm going to go right back up to this line where I factored, and I have x cannot equal a positive 4 over 3. Sorry about that. All right, we have 2 more examples left. So again, write this one down, pause the video, and try and factor this yourself. Hopefully you recognize that that denominator was a difference of squares, so we could factor that to x squared minus 4 and x squared plus 4. And when I look at this new denominator, I again have another difference of squares here where I can factor further. All right, so I factored that difference of squares. I also realized I didn't factor my numerator, so sorry about that. At this point, I can write my restrictions. X cannot equal -2, x cannot equal positive 2, and there's nothing that I could plug in here that would make that 0, so we're good there. I can cancel out these, and what I'm left with is 3 over x minus 2, x squared plus 4. All right, last example, and when I first look at this, I think to myself, I just don't love the way that this is written. I'm going to rewrite it, and I'm going to put the -2x squared first, then the -5x, and then the plus 12, and hopefully that will make it a little bit easier for me to think about when I'm factoring. So go ahead, pause this, factor it, and then come on back. So we have a couple of things right here. Some of you may have just common factored out a negative from the beginning, and that's totally fine. If you did that, you'll be one step further. If you didn't and you got what I got right here, you're going to notice that we have a very similar situation as before, where we have a -2x plus 3 and a 2x minus 3. So what I am going to do is take a negative outside from this bracket right here. That turns this into a 2x minus 3. From here, I can go ahead and write my restrictions just so that I don't forget. X cannot be 3 over 2, and x cannot be 2. I can cancel out these guys, and I'm going to be left with a -x plus 4 over x minus 2.